It's great to have you back. It's great to be back, and we're really excited about this year's academic year's program. I am physics professor Tim Chupp, one of the organizers of Saturday Morning Physics, along with my colleague Professor Rachel Goldman, and the rest of the team, including Carol Raybuck. It's dark in this room, but she's in the back, and she does so much to help organize this. And Monica Wood. And Monica's staff of the Warren M. Smith Demo Lab. We've put together an exciting and fascinating program of presentations for the fall, with today's presentation and 4 more covering the science of election security, the formation of galaxies, and the health of the Great Lakes. And the Winter-Spring series is going to be equally as fascinating and as exciting, so we look forward to seeing you at every one of these events. Today's lecture and question and answer session will be hosted by Professor Rachel Goldman, but first, it's my privilege to introduce a longtime Saturday Morning Physics fan, but most importantly, a Saturday Morning Physics presenter. You may remember the amazing pre-eclipse event from last winter. I'd like to introduce now Physics Department Chair and Professor of Physics and Astronomy, David Gerdes.
Thank you, Tim. Good morning, everybody. It's great to see you as best I can in the glare of these lights, and I think Tim is right that the last time I talked with you all was last February before the solar eclipse, and so I got to ask with a show of hands, how many of you managed to go see the total eclipse? Wonderful, fantastic. I went to Texas and got totally clouded out. It got dark, that was cool. We heard an owl and that was cool, but didn't get to see the big show, so I'm really happy for those of you who did. I was reflecting on the way in this morning about the fact that Saturday Morning Physics has been going on now for, I think, close to 30 years. And I was thinking about what accounts for its enduring appeal with this community, and I think it is rooted in the fact that we bring together 2 different things that are often not found together in combination. That is expertise and the ability to communicate that expertise in a way that is fun and relatable and comes with coffee and donuts. Today's talk really exemplifies that, the way that no pressure or anything, but it exemplifies that in the way that we can communicate complicated scientific concepts through pictures and through comics, through sort of a children's medium, but on very sophisticated subjects. And that same thing characterizes the rest of the schedule for this fall. Expertise, as we know, is very hard-earned and difficult to come by, but we now live in a world of misinformation and a world where people can claim to be experts on the basis of having watched a few YouTube videos. We really know it's harder than that, and what makes Saturday Morning Physics so special is that we bring real experts in to talk with us about important issues of our time, not just scientific issues, but these issues of election security and the health of the Great Lakes, AI and how it is transforming all aspects of society. So when we come here for that, we are reaffirming our commitment to these values of expertise and its impact on society. And of course, we're able to do all of this because of your generous support. Every year I am blown away by the gifts that we receive to help support Saturday Morning Physics. It costs about $5,000 to put on each one of these events, including support for our staff, for publicity, for the media, for advertising, and so on. And I am just incredibly grateful for all of you who have supported us in the past. If you have not supported us before, please consider doing so. And if you're not ready to make that commitment, you can still give back to Saturday Morning Physics by helping spread the word among your friends and acquaintances about the value of this programming. So thank you for everything you do to make all this possible. And now I would like to turn it over. One more thing before we get to our speaker. I'm going to introduce my colleague Rachel Goldman, who will introduce today's speaker. Thank you.
Good morning, everyone. Can you hear me? Okay, I'm very happy to introduce Jim Ottaviani, and he's going to talk to us about comics about science, and there are a few more words in the title, which I won't read. As many of you know, perhaps all of you, Jim is the author of 15 and counting graphic novels about scientists. Those of us with young kids know that these are amongst the first books that our kids take and read by themselves. We've already seen a few kids come down here and get signatures. And some of the work include Einstein, that's illustrated by Leland Merrick, The Imitation Game, which is a biography of Alan Turing, Primates, which is a favorite. We have a signed copy in the audience. Where am I? Feynman, with Leland Merrick, a book about the Nobel Prize-winning physicist, a bongo-playing artist, and raconteur, which debuted as the #1 New York Times bestseller for graphic novels. The books have been translated into over a dozen languages and are probably the only ones to have received praise from both Nature and Vampirella magazine, and everything in between, from Physics World to Entertainment Weekly to Discover to Variety to Time. So Jim came to comics via his careers in engineering and librarianship. He has bachelor's and master's degrees in nuclear engineering and a master's degree in information and library science. He's a published author in both of those fields as well. In addition to being a writer, he's a librarian emeritus at the University of Michigan and a NASA JPL Solar System Ambassador. I'd like to find out more about what that means. When he's not writing or running trails, he also gives talks on comics and science in venues ranging from public libraries in small Michigan towns to bookstores around the country, universities in Canada and the US, and he's traveled all the way to the Nobel Museum in Stockholm to present on comics about scientists. So, without further ado, I'm very happy to present to you Jim Ottaviani, and really looking forward to your presentation.
Thanks, Professor Goldman, Professor Chupp. I don't know if I can live up to my introduction, but I'll try. This is going to be a little bit physics light, though, because it would be kind of crazy to talk too heavy physics in an audience like this. But so to begin, Richard Feynman, everybody's favorite safecracker, bongo player, gallery artist, best-selling author, adventurer, Nobel Prize-winning physicist, liked to start his introductory physics lectures with this experiment. It's a dramatic way to show that you can trust science and at the same time trust him. And it showed he wasn't too serious either. And to that end, here's one of his favorite quotes. It's from the title page of one of his favorite books as a kid, which was called Calculus Made Easy. It's how he taught himself calculus when he was little. And it took me a while to get the joke of ancient simian proverb, but I got it as I was putting together this slide. But to the point of the quote, I'm not Feynman, and as evidence of the fact that I'm not a fool, in a room full of people who can actually do physics, I'm not going to talk much about physics. Sure, if we were walking down the street, I've probably taken more classes in quantum mechanics and done more problem sets in neutron interaction theory. One of my masters was, actually 2 of my masters were from here. So the pedigree is pretty good. So I've done more physics than most people on average, but we are on Church Street, not on Main Street. And I know that I'd better stay in my lane. So I'm going to talk about storytelling in comics and only kind of wave at quantum electrodynamics, Penrose diagrams, and general relativity theory from kind of across the room here. But after saying all that, let's do something adjacent to science at least and talk a little bit about how comics work. So this is the theory section. Whoops, I went too fast. So we all know how to write words, and we've all drawn pictures. Those are the atoms, molecules is probably a better way to describe them, from which comics are made. And the point is, there's a deliberate sequence of images and words that we use to tell a story. And it's that sequence that matters a great deal in life, but certainly in comics. We all know the sequence of letters matters. I mean, have a look. That's not Shakespeare. But with some work, you can get to Much Ado About Nothing, right? But we don't often think about the sequences of images. I mean, is this comics? I would argue no. It's the sequence that matters, and you only communicate an important idea if you get it right. So, now with the idea of sequences of words and pictures in your head, let's do one of the favorite things that physicists do, a Gedanken experiment, a thought experiment. Imagine, if you will, maybe even close your eyes, that you're in the best possible bookstore or library ever, and it's got two really long aisles. And on one side is the humanities, where all the great works of literature and stuff are, and on the other side is the science section. And as you walk down that aisle and you pick up the books and you flip through them, on which side do you see all the pictures, or books that are full of pictures? I would argue, and I think I'd be right, that you'll find most of the pictures, most of the time, in science texts, or in just books about science. So images are unnatural, I would say, for communicating ideas, especially scientific ideas. Avoid images, and you avoid clear communication. Here is Isaac Newton doing his darndest to avoid clear communication. This is one of his alchemical texts, and I don't know if you know the history of alchemy, and I don't know it in detail either, but one of the things was to try to stake a claim for a discovery, which was usually nonsense, in print, but without really telling anybody how you did it or what happened. And to do that well, avoid using pictures, and this is Newton doing just that. I have no idea what he was claiming to have discovered here, whether this is yet another example of trying to get from lead to gold without an actual nuclear reactor, which he would have had to wait 500 years or so for. But anyway, if you want to communicate clearly, you use pictures and images, is my argument. So let's do a quick survey of pictures and images through the last few thousand years. Many of these images come from John Barrow's terrific book, Cosmic Imagery. So we'll start with math, which I promised in the subtitle of this talk is actually really hard to do well in comics. But diagrams like this explaining how to calculate the square root of 2 in cuneiform showed up as long ago as 1700 BCE. Fast forward a lot of years, and we get the Copernican revolution started by who else but Copernicus, talking about a radical new theory, a radical new idea about how the solar system is arranged. A few years later, we get one of the first pop-up books ever. And this is Euclid's Elements as a pop-up form by Billingsley and Day. Jump ahead a little bit further, and we get the further evolution of the solar system models, this time by Riccioli, summarizing an even more modern view of the universe, post-Copernicus. Newton again, this time actually telling us something. And you're almost, kind of, sort of, maybe getting some sequential art here. You're getting the flow and passage of time, or at least a few photons through light. Further ahead in time still, we have Charles Darwin, and I would argue we're getting even closer to sequential art here as he talks about the changes that the finches go through on Galapagos Island as they separate and adapt to their particular niches. Hubble, talking about the evolution of galaxies. It's just amazing to me to think that it wasn't that long ago that we had no idea that there were other galaxies, much less that it's expanding and all running away from us as if we were like in an election year or something. And then we return to our favorite, or at least one of my favorites, Richard Feynman. Again, we have a little bit of sequential art here, all in one of these extremely clever and useful diagrams. And then finally, I'll stop with Gordon Moore and his first graph of Moore's law, which talks about how semiconductor density and computing power doubles roughly every 18 months. And I think that's appropriate, since image use is also doubling roughly every 18 months. Which, of course, is a fact that I made up, so don't quote that, but I wouldn't be surprised if it's close to true. Because, which would you rather look at? And this is the table of Moore's data versus this graph, which shows, I think I've got this all the way current to, yeah, into the 2020s, that remarkably Moore's law is still holding. So why do we do this? Why do images work, and why do comics work even better? If you have aphantasia, the inability to actually picture something when it is described to you in words, it's hard for me to believe because I am trained as an engineer, and I would expect a lot of folks here have pretty good visual imaginations. Just as an aside, when I first started doing comics, a lot of the people in, I'll say, the humanities thought this was a nutty idea. No scientist or engineer, including all the people that I've worked with and profiled, who are still alive anyway, ever found this weird. They thought, oh yeah, that makes sense. You should do that. But there are people with aphantasia who cannot picture things, and comics are a particularly good aid for those folks because the image then is presented directly to them. Now they're rare, but in comics, both the abstract and the concrete processes in your brain are engaged. Now, there are some people who get way more out of images and even more out of text and numbers than others. Feynman, we're going to come back to him frequently today. For instance, almost certainly had grapheme color synesthesia, in that he saw equations, numbers, everything in color. And in one of his books, he said a little bit spicier version of, I have no idea what the heck my students are seeing. But this is the way he saw the world. But all of us, from those with aphantasia to synesthesia and everywhere in between, kind of sort of see the world in comics terms all the time anyway. And here's why I say that. It's because of a thing called saccades. Are people familiar with saccades? Anybody know what that is? Yeah, some folks know. That when you are looking straight at somebody, you are actually not really looking straight at somebody. Your eyes twitch back and forth, up and down, all the time. They're constantly in very tiny motion, building up a picture of the world, so that when you look at a face, when you look at me, when you look at your neighbor, when you look at something, what you're really doing with your eyes, if you track that motion, is building a picture like this, which sure doesn't seem too far from drawing stick figures with your eyes all the time. So as you make a stick figure for me, and and those around you, let's move away from the why and get to my field, engineering, and how these things are made. So, by way of introduction, I'm going to spend a little time talking about how comics get made, and Feynman was noted for his affinity for mischief. In particular, safe cracking at Los Alamos during the Manhattan Project. And here's what he had to say about how to. People love it. They want to know a little bit what things are going on. And again, I have lied to you because that's actually George Roy Hill, the director of Butch Cassidy and the Sundance Kid, The Sting, and a number of movies that you might have also seen. But Feynman did say something very close to this, and I think it's true. People love to learn, et cetera, et cetera. And I think they're both right, George Roy Hill and Feynman. I mean, otherwise we wouldn't be on campus here on a Saturday morning talking about physics, or something close to it at least. So let's do a little bit of discussion about how comics get made, at least in the way that I do them. And for this, I'm going to use examples from the Hawking book that I did with my friend and colleague Leland Myrick. And it's a book that wouldn't have happened without U of M physics. Very specifically, I want to say it's U of M's own Gordy Kane and Lois Kane, who suggested that I do this in the first place. Then a few months later, I used to tutor with Lois over at 826 Michigan. She said, you know, it's Stephen's birthday in a few weeks. You should go. And it's like, yeah, I should just hop on a plane to Cambridge and crash Stephen Hawking's birthday party. That didn't seem like a very sensible thing to do at the time. But eventually, I did learn that Hawking liked the graphic novels, and we got to do this book. More on that later. I would never have seen, but to sum up, I would never have seen the view from inside Hawking's bedroom without Lois and Gordy. So thank you. And with those words of thanks, we're going to talk about words. We use words in comics in a fairly straightforward way, oftentimes. Left to right, top to bottom, the way we usually read things in the West. But you can also use them visually as well, and that's most of what I think I'm going to talk about right now. For instance, here's an example from early on in the book. Stephen Hawking is a young man, and he's speaking, I think you can tell, in Hawkingese, which is all the words jammed together, and he's going really fast. That would look very awkward and bad, I think, in a prose biography, but in comics, as I'm going to say probably more than once, you're already used to reading and you're already used to processing things visually as well as verbally. So you kind of get the picture of what he's doing as we jam those words together. And of course, his speech changed over the course of his life. Eventually, he had that very famous computer-generated voice, and that's easy to do too. Very easy to depict in comics as well, so you can show that shift. And in between, his voice started to fade away, and he became indistinct and difficult to understand. And so with the help of color, you can also give some indication of what's happening as his ability to speak leaves him. Now, in comics, we can also get inside people's heads fairly easily. I am a person who is always bothered in movies when all of a sudden a voiceover intrudes on a scene, because it's like there's never a voice telling me that I'm walking down the street worried about the Saturday morning physics talk. That's all in my head. In comics, again, because you're used to reading, you can show what's going on in people's heads visually here. We also get to use captions and labels and sound effects and all those things. One of the challenges with doing books like I've done is you can't just leave out most of the people for the sake of simplicity. You want to give credit where credit is due. But there's often not an elegant way to introduce people other than to just give them a name and a label right there. But you can give that voiceover and you can do all those things. And again, because you're already in the habit of reading, I think it feels a little bit more natural than it would in film or in plays where it's like, oh, Hamlet, good to see you, which is how you have to introduce, I mean, Shakespeare was better than that. But you can also use words just on their own when it's just too difficult, and this was one of the challenges with the Hawking book, when it's just too difficult to visualize things directly. And this is how you cheat in comics. So, that's words. Let's talk about pictures. Because in the end, comics mean using pictures. It wouldn't be a comic without pictures. And we'll start with leaving the words out completely. And this is a particularly effective technique, I think, for showing subtle emotions and oftentimes deep emotions as well, but I think it's best when showing someone getting a little disappointed and perhaps even disappointed with himself. And we can use words as pictures. A lot of times in the books that I do, nobody's going to be able to get a PhD in cosmology or in quantum electrodynamics by reading one of the books, one of my graphic novels. Just sorry. So I don't necessarily expect people to read the equations and understand the equations. But what you get when you do something like this is a visual cue that science is happening in somebody's head right now. You don't have to parse it. You don't have to understand it necessarily. You just have to know that Stephen Hawking is thinking about this stuff while he's brushing his teeth. One of my favorite things about comics is to use words in counterpoint to what you're seeing. Hawking was not honest with himself in terms of how good he was as a cox on the crew in the rowing team at Cambridge. He thought he was excellent. I don't think his teammates thought that the same way. And you can also use color specifically to indicate passage of time. When we go back in time, I'm a big fan of the sepia faded photo sort of look. And this is Henrietta Leavitt helping Hubble figure out that galaxies actually exist and stuff. And then there's finally the time-honored tradition of super exaggeration to get across the motion, the liveliness of these characters and what happens to them, even in a static medium. So now let's talk about words and pictures together. Because we've talked about them separately, the best storytelling, I think, happens when they do more than just repeat each other. Because we've all been to presentations, right? You know, the bad ones where the speaker reads from the slides and it has too many bullet points and adds nothing new to what you see. That is not a fun presentation to be at. Much better, I think, is to add, oh gosh, I didn't mean for those to fade into each other. Well, did that make you dizzy? Because the point of those slides from the book that I did about Niels Bohr was to illustrate that quote, perhaps famous, but maybe not everybody knows it. Anybody who can think about quantum physics without getting dizzy isn't understanding it. And so we spun people around, we spun some of the words around in that panel, and then I inadvertently added too many special effects on my slide to make you even dizzier and more annoyed by quantum mechanics. Sorry about that. But to that example, you don't want to take these things too far. And here's one of the weaknesses and challenges of doing comics, and it's getting the reading order right. So here's what a script page that one of my poor, long-suffering artists has to deal with when they are presented with, when it's time to draw the book. This is actually one of the shorter ones in terms of my description of what's in a panel. So you can just imagine how much reading there is to do. But figuring out where to read and what to look at next is pretty straightforward in this. Again, in Western style prose, left to right, top to bottom. You know where to go. When you turn it into comics, though, you end up with images, right? And then you have to layer on that text. And once you do that, perhaps you can see the problem that Leland and I saw in this page. What are you supposed to read first? What are you supposed to read second? Which way to go from one spot to another? I mean, is this the right order? This is valid too. The thought continues the thought. Or you could maybe go like that, because the biggest block of prose is in the upper right, but that's wrong for Western readers. So, something wasn't working there, and we had to fix it. And I don't know if you can tell from the somewhat blurry image, but I never created a high-resolution version of this because I didn't need to, and because I really didn't want Leland to have to redraw the Palomar Observatory. And he really didn't want to do it either. So what we did was, we took that first panel on that page and flopped it, like you looked at it in a mirror. And once the text is back on there, now I'm pretty sure, that reading order makes more sense. It's at a slight cost of authenticity, because that's not exactly how Hubble would have been looking. And we don't like to have characters facing away from the end of the page if they're doing something that is to indicate, to bring you further into the page. But better that than to confuse people in the way that they're supposed to look at this thing and what you want to do, especially in the first panel. In the second panel with Henrietta Leavitt, it's okay. But we didn't want to have to redraw everything. So, with those things in mind, let us move to storytelling. And we'll use Einstein as an example of that. And this is a book that I did with my friend Gerald Dye. And this was something that our publisher was really keen on seeing, because for some reason they didn't think there were enough books about Einstein out there. But I was glad to do it, because Einstein is, of course, a fascinating and interesting character. So, and in part because as I thought about this more and more, I thought of Einstein as maybe the perfect example of what we can do in comics. Because for Einstein, space and time, with Einstein's theories, I should say, space and time became inextricably bound in our minds. And so in comics, there are a lot of ways to transition from panel to panel, but basically, what you almost always see is a moment-to-moment transition. So the spot in between the panels, what we call the gutter, and I think I'll have a slide reminding you of that shortly, indicates the passage of time. Now, you can play with that as well. And in the Einstein book, what we did was, if there are bigger leaps in time, we separated those gutters even further than what you would see to indicate that we are moving back and forth. We've also got some captions there, and to introduce the Hollywood stars that Einstein hobnobbed with once he got out here, out into the US. Another thing that we did, and here's no great passage of time in between these panels, another thing that we were able to do and wanted to do with the Einstein book was allow some of the characters, never Einstein, to talk to us. And I don't know if you've noticed in comics when you've read them, most captions, when people talk, they talk in word balloons, and they're kind of oval shaped or circular shape or some sort of round blobby shape. And when there's captions or voiceover or things like that, they come in more rectangular boxes. And to solve the problem of determining when, for instance, Mileva, his first wife, is talking to Einstein versus when he's talking to us, we just were able to square off the boxes and give the reader a hint that she's not actually addressing her husband there. Because why would she? He's always thinking about physics. And when we're doing comics, we want to be able to layer the information in this way. So we've got Einstein overlaid on his thoughts and sometimes speech overlaid on top of what Einstein is thinking. And I think this gives a richness for storytelling that is difficult to get in any other medium. Straight up prose, plays, movies, it's hard to do. A lot of what we do in comics then is metaphor, and it's typically a visual metaphor. And that's, I think, the most important tool we have. We talked about symbols, we talked about graphs a little bit before, one thing representing another. And for Einstein, who loved music, the violin in particular, he spends the whole book trying to find the perfect instrument upon which the music of the spheres, if you will, the universe, was played. So over the course of the book, we see him reaching for music, trying to create this perfect imagined instrument to represent general relativity theory, the general theory of relativity, and then his next goal, which was the unified field theory. Spoiler, he gets there with relativity, he does not get there with the unified field theory. And as he tries for that unified field theory, he starts messing with this beautiful instrument that he's created, adding frets to the neck and extra necks and all sorts of weird stuff until you get this kind of monstrous, weird-looking violin that doesn't actually do what Einstein wanted to do. He can't make his theory conform to his ideal, I guess, of a static, unchanging universe. And so he keeps changing that violin. And when I think about, and talking about changing, we were able to do one other thing that I think can be difficult to do in other medium, and that's changing the way things look throughout the course of the book. Now, we're all familiar with cartoons and comic strips and things like that, and I like to think of them as happening on a spectrum from very realistic, like the old-time Prince Valiant comic strip that's still running and still beautifully drawn, to the very, very cartoony, if you think Calvin and Hobbes, Peanuts, or one of my recent favorites, Cul-de-sac by Richard Thompson. You go from people who look very much like people to people who sort of suggest people, but don't really look all that similar to who you would see walking down the street. So in the Einstein book, as we progressed from him being an obscure, unknown German physicist to an international icon, sort of a symbol for genius, we go from a fairly realistic, within the bounds of what Gerald was comfortable drawing anyway, he's not a super realistic guy, to a very, very cartoony Einstein. Thicker lines, bolder iconography. He loses some fingers, the way cartoon characters often do. In realism, you have 5. You usually end up with 3 if they're really cartoony people, because it just gets in the way to draw all of them. And in that progression, we tried to, like I say, visually indicate that Einstein is changing in the eye of the public. So as Einstein moves from this obscure physicist to an international icon, we do all these things in service of showing that he's becoming famous for, he's becoming a Nobel Prize-winning physicist, for the general relativity. He's the guy who failed math class but ends up being this perfect genius. All those things that are, in fact, again, not true because, of course, Einstein won the Nobel Prize for the photoelectric effect laws that he discovered. And he did not fail math class. This was a myth that was perpetuated because in between 2 years in, I think it was closer to high school, they changed the grading system so that 1 became highest grade and 6 became lowest, or vice versa. And so he got a 1 one year and a 6 one next year, and somehow it fell into the popular culture that he must have failed one of those years, which is not, in fact, what happens. Oh yeah, and he wrote that equation about the atomic bomb too. Again, all of which is not quite right, and we address this stuff in our book, but oddly enough, to me anyway, Einstein didn't. And it wasn't for the reason that Feynman again, the reason that Feynman said. I'm not sure why, but in the autobiographical notes that Einstein left about himself, he devotes a few pages, maybe 10% of the whole thing, to his youth. And even then, it's mostly about what he read and thought about physics back then. And the rest is, here's what I think about relativity theory right now. It's all interior, all physics, almost no context, and no outside life or interests for him, even though he played violin, he loved sailing, he did all these things. In his notes, Einstein has a father who apparently limited his role to giving Einstein a compass when he was 4 or 5, and then he leaves the scene. He had 2 teachers and 12 predecessors in science, only one of whom is worthy of being named and depicted in the book. The rest, nothing else exists. Family, 2 wives, 3 children, friends, including people who helped him with relativity theory, like Michel Besso and Marcel Grossman, completely absent. Peers, none of those either. Not even Niels Bohr, a colleague who he had famous and wonderful disagreements with about quantum mechanics. Not even Bohr appears. And this omission in particular, especially because I'm a big fan of Niels Bohr, seems weird to me, but maybe it's because Einstein loved him? I don't know. But Bohr isn't really in his autobiography. But what we know about Einstein is that he cared about physics. He lived it and breathed it, thought about it constantly. So one of the challenges of the book was to get that across. I always try to show readers what it was like to be the main character in one of these stories, in their own story. Sometimes that means taking poetic license to flesh out scenes or anecdotes that don't get a lot of attention, or, like we just did briefly, bust a few myths. But sometimes you do make up stuff, and I will confess that in the Einstein book there is one scene, and I'm not going to show you, that is completely made up, except for the fact that Einstein said what he said, just in a different context, and the situation happened the way we depict it, just in a different context. But I would promise you that if you do end up reading the book, you will not be fooled as to whether this thing is true, just because of the way, where it is and how we show it. So what you get, I think, is instead of a biography with the type of things that I'm doing, is you get a story. And I think stories are really important. Anybody who's written a grant application knows they have to tell a little bit of a story. Anybody who's trying to communicate what they're doing to someone who is a non-expert has to tell a little bit of a story. And sometimes that means strategically adding stuff that is merely fun, or leaving stuff out that doesn't help. And that brings me back to Feynman, of course, and this quote that he gave to a German publisher. So are people familiar with Surely You're Joking, Mr. Feynman, one of his very famous books, full of terrific anecdotes, really fun. The German publisher gets a hold of it and is in the process of translating and says, you know, I'm gonna butcher, sorry, apologies to my wife who speaks German well, but Herr Dr. Professor Feynman, they said, there are some of these things that just aren't important to German readers, so I think we should leave them out. And this was Feynman's response. He said, no way, take it as it is, or don't publish it at all, because I do some of these things just to make this more entertaining. And I think Feynman knew these two things about talking about physics, talking about his work, talking about his life. Stories are more important, the story is greater than the sum of the parts. And what's important is not the same as what is important to a specialist reader. So people ask me, what do you leave out? How do you leave out? And Feynman, for the example of Feynman anyway, he wrote a lot of popular books. I'm not sure that the lectures on physics would be considered popular technically, but they are very readable as lectures. He wrote all these things, and I would occasionally get someone who come up, it's like, I feel like I've read all those stories that were in your book. And then I said, I've actually done the math, and this is the percentage of those stories that are shown that we used. A lot of the rest of the material is new that you wouldn't have only read if you were at the Feynman archives in Caltech. It's about 23%. So what I wanted to communicate is, even though you think you've seen it all, you probably haven't, and you probably don't want to see it all repeated. So what I tried to do with these graphic novels, and what we're doing is tell some of what's useful to get a narrative arc, knowing that there's a lot more out there. Like I said, there's hundreds of books about Einstein. Feynman wrote plenty of books about himself. I don't think he had ego issues. And so there's always more out there. The thing that you have to be the most careful, and the thing that I had to worry the most about, I would say, is the physics and what to leave in and what to leave out with that. And here again, I would take the Feynman approach. I do not want to bonk at things. I want to tap at things to give people a sense of what it's like to discover some fundamental laws, to create these things that are useful and important. Because if you showed it all, the book would probably get boring. Nobody wants 400 pages of I worked hard late into the night. That's just not visually terribly interesting. And so you do have to leave stuff out. Now, we did leave some quantum electrodynamics in, though. Not enough for you to get a PhD, like I said, but enough to give a feel for what it's like to solve these problems, to maybe, I hope, entertain you by understanding a little something. And Feynman's work is at an advantage in this case because it's very visual. I found, even though Hawking has Penrose diagrams to aid him, I found those difficult to decipher and make decipherable for people. And Einstein was even more abstract, frankly. But I did want, like I said, to give the reader a sense of understanding a little bit of something of what's going on, to give them, and to make it feel like it was part of the story, not separate from the story, because showing it all would slow everything down. And if you wanted to give the whole thing, well, that would be impossible. Just like Feynman's cabbie said, if you could do it real fast, it wouldn't be worth a Nobel Prize. So unless you're talking to people who need to replicate your work, maybe consider leaving some things out. So I'll close with the question again. What would Feynman do when confronted with the notion of art about science? I've read a lot of his work and have had the good fortune to talk to people who knew him pretty well. So I think I know, but don't take my word for it. Let me set the scene for you. Feynman was a stamp collector when he was a kid, and he was intrigued by these triangular stamps that he got from a place called Tuva, Tanu Tuva. This is a stamp that an artist named Michael Munday made to commemorate Feynman's love for Tuva. But Tuva was a real place. Even though it was kind of absorbed in the Soviet Union at the time Feynman was alive. And when he mentioned this to his friend Ralph and to his kids and his wife, they didn't believe him, so they dug up this old atlas, found it like buried in tiny print in the middle. I think it's in the region of Mongolia. He pulled out his stamp collection, showed him the stamps, and they immediately at that dinner where they were talking about this said, we got to find a way to get there. But it's going to be hard because it was in a restricted area. It's the Soviet Union. This is the 80s. It's just not easy to move around. So what did Feynman do? So I offered to give lectures in Russia. And by this time he's world famous. And they will be very excited, I think. So I say, but to do this, I want to go to Tuva. And they'll say, fine, of course. And then I say, having learned a bit, you see, I want to give the lectures after I go to Tuva. And I think they'll have to agree to that. And so from there, I would say he's got what we would call a Gedanken experiment. He knows how to get this done, or he thinks he knows. He's got a theory. He's got a way to test it. But if we were watching the video, you would see that we cut him off right in mid-sentence. So let's see if we can play the rest of it. And we cannot. So this is his friend Ralph Layton, who he tried to get to Tuva with and who was the sort of as-told-to guy in his books. And so what does Feynman do? He says, but I don't want to do it that way. I want to go, and now I'm going to strongly paraphrase, I want to go to the Soviet Union embassy and get a visa and find our way over there on a twin-engine plane. I'm adding details here. And I just want to go at a lower level. I don't want to just like drive down the highway and stay at the Holiday Inn to do this. And so what I would suggest is he had it. He had science or engineering in the palms of his hands. He knew how to do something. And he chose instead to make life into a little bit of art. Do it the harder way. Do it the way where it's full of unknowns. So is art a lower level than science? And comics about science being an art, being a lower level, follow that trail down? I don't think so. For many, comics aren't even art, and they are a lower level. Especially when I started doing this about 20 years ago, comics were kind of disreputable. And doing comics about science, well, my first proposals to publishers went like this, or their response went like this: that's a neat idea. I can't wait to read it when somebody else publishes it. So did we do the right thing? Do Leland and Gerald and I feel guilty or even concerned about lives of science being represented by art? Do I worry about leaving a little bit of truth out in favor of story? Well, do I worry about using such a simple medium to tell these stories? Well, I'll leave that for you to think about and decide what you think. We know what Feynman thought, or we would have known if we could have seen him on video. And I have it I was going to say firsthand, but secondhand via Lois and Gordy, what Hawking thought about graphic novels about science. I'm not sure about Einstein or, in fact, Darwin, because once again, I lied to you for the sake of a little bit of storytelling fun. But I think I know where both Darwin and Einstein would stand. And I hope you give comics a chance sometime, some way, and figure out what you think about it. And that's where I am. And again, I'm really sorry you didn't get to hear Feynman in his Brooklyn accent. So good. Nope.
Sound right? Okay. So we have, we'll start with the first question that was emailed. Doesn't the fact that a cartoon panel may be read in assorted orders, red or arrows showing direction and sequence, render a dimension of communication, discovery, engagement beyond that possible with linear prose?
That's an easy one. I think yes is the answer. So yeah, when we put together comics pages, we try to lay them out so that there is a straightforward reading order, but at the same time, you realize when you're making these things that, let's talk about print only, as you turn the page, you can't help but see the things that you're seeing. It's all there in front of you right away, and if the images are good and compelling and exciting, you're going to notice stuff even before you start reading the words. So the answer to that is yes. One of the things that you want to be careful about is if you've got a surprise or something that's going to happen in the page, stick that on an odd number page so it's hidden by the page turn, so that, something that is meant to startle, surprise, whatever, isn't immediately available to the reader right away. They have to turn the page and at least get through the bit that you wanted them to see beforehand before they get to see that thing. That was inelegantly put, but I think you know what I mean.
Thank you for the lecture, and thank you for making me feel more comfortable about my PowerPoint videos. Maybe if they're YouTube linkable, and this is going to be published online, is it possible to slide that into the comments somewhere? I'm very interested to follow up and learn more about what Feynman had to say and this sort of take the path less traveled, more unknowns.
Yeah, I can't remember where I got those videos now, but it's probably out there. Yeah. My pen ran out, so I don't have a...
Thank you.
Somebody will remind me. Yes. Although, again, maybe fair warning, I edited those very carefully to make a point. To make a point. Yeah.
Can you bring him?
Yes. Can we get the microphone so the audience online can hear you as well?
Sorry, I'm just getting it out. Okay, here you are.
Your best guess as to the age group that you're shooting at. And it probably varies from one book to another.
It does.
But especially for the physics end of it.
So yeah, there are basically two age groups that I've shot at. So Professor Goldman mentioned primates, and there have been a couple other books that are kind of targeted to like 10 to 12-year-olds and up who are bringing their A game to the reading that day. And then there are books like the Feynman book, the Einstein book, the Hawking book, which I think of as high school on up. So it depends on the kid too, especially with, relative to the older books, because you never want to say, oh no, that's too much for somebody, because who knows? And kids will typically take from a book what they want and need at the time anyway. And so I think maybe there's a dam occasionally in some of these books or whatever, but there's nothing in there. They're books for adults, but they're not quote unquote adult content books. So if somebody picks one up and, likes seeing Feynman wave his arms around, showing you how he's figured out how mirrors work, hey, that's great. And maybe they'll come back later and read it in more depth, and then, a few years later pick up his terrific book QED and learn it from the horse's mouth, so to speak. So, yeah.
Do you have one on David Bohm, or have you thought about doing one?
David Bohm has been suggested multiple times, and I have thought about it. So here's where life gets a little harder and capitalism's brutal heel crushes down. I have not yet been able to sell anybody on the idea that David Bohm is exciting and interesting enough for a full graphic novel. I haven't tried super hard, so I should come clean on that. But I talked to my agent, and I can just hear her right now. She would say, that sounds like an indie book. So self-publish that one through Lulu or whatever. I was like, okay.
I have a two-part question. What has been your favorite scientist to work on, and what would be your next favorite to work on in the future?
Oh, wow. Favorite of anything is always unfair, right? But I will say, I think Feynman is a terrific character. I don't know that he would have liked me, and I'm not sure that I would have enjoyed being. He seems like a guy who would have been exhausting to be a friend with. Just like, oh my God, man, can we just stop for a second and, maybe go to the Holiday Inn tonight rather than sleep on the side of the road? I'm tired. So I would probably go with Niels Bohr because he seemed like the kindest of the physicists that I have encountered. And he also had a pretty wide range of interests. He liked outdoor stuff. He liked hiking and things, and I like that too. Next book, there are a couple. One is not yet, the fate of that is not yet sealed either way, but I'd be very excited to do it, but I shouldn't say anything. The negotiations are happening with a university press for the rights, and holy cats. And I was at the university for 30 years. I was like, this is going to take a while, just so you know. But I've got a couple others coming up that are sort of ensemble casts. One about women divers, deep sea exploration. So getting to talk with Sylvia Earle, and then a cave diver named Jill Heinerth, and then the women of minorities and shark sciences. That's been pretty cool so far. I am not a diver. I've done a little bit of snorkeling is all, but my friend Maris, who did the primates book, is on tap to do this, and she is a diver, and we're pretty excited about that one. So, yeah.
Thank you.
Any other questions from online? Oh, there. Can you take the mic up for her?
Thank you for that. So I was just wondering, so everything you showed today, and I'm very new, I hadn't heard of this before, so I'm very excited to see it.
Cool.
But everything I saw here was very heavily gendered towards men and who you're representing. So I'm just wondering if there's opportunities to expand or interest in expanding into more the female STEM view, but also what that would change in your approach on how to kind of evolve the graphics, et cetera, and whether you see a gendering of readership to, your graphics.
Yeah. I picked the 3 big name physicists for Saturday morning physics. I have a book called Dignifying Science that's all women scientists. Primates is all women scientists. In another book I did with Maris, Astronauts, was about the first women astronaut group. So I've tried to get to some of that. I wouldn't say the approach is different. The only aggressive, conscious decision was for those books was it's got to be a woman illustrator to do this, because it would be kind of weird. I can't change who I am, but I can certainly say women should be illustrating these books specifically. And there have been women illustrators in some of the other ensemble books that I've done too, but these specifically were. But yeah, approach. What do you think? I don't know how you, I don't know why, at least on the science side, it would be different. Obviously, women face, the stereotypical, I'll use the, ridiculous Ginger Rogers quote. Yeah, I did everything that Fred Astaire did, but backwards in high heels. And so women have to step up 3 more steps just to get to play the game or to get to do the stuff. So it's harder, obviously. And we attempt to depict those challenges. But once you get there, they're doing the work the same as others.
Yeah, I think my question was more on, so I don't know in terms of distribution how many young women versus young men read graphic novels and whether they can be made more approachable if there is a gender disparity between kind of wanting to read graphic novels. I have one of each at home, and my boy is the one that goes after the graphic novels, and it's kind of this action-packed, and it seems very unfortunately gendered at home.
Yeah.
So I'm just wondering if also from the illustration point of view and kind of how the stories are told, whether you see differences in depending on which demographic you're trying to approach there.
Yeah, now that you phrase it that way, I think I see a way to answer your question. It may not be the right answer. And I also kind of want to give an aside, but first I'll say, I think the style of art matters a lot, and the woman I've worked with for the Astronauts and Primates books, Maris, and who is also going to do the Divers book, has a very cartoony style, which I think for those readers who grew up on, say, Raina Telgemeier and books like hers, is more appealing than, the stereotypical superhero-y, bulked up, hyper everything aspect of those books. In terms of readership, I mean, the data are clear. Just readership, broadly speaking, girls read more than boys, way more. And in terms of comics, especially if you're looking at manga, the Asian imports from Asia, Japan, Korea, China, etc., girls read more of that too, typically. And I will tell you a story, and I'll try to leave the bad word out. But there's a guy named Scott McCloud who's done a number of books about comics, Understanding Comics being his most famous. He was at a residency at EMU over in Ipsy a few years ago, and we got to know him a little bit and hang out with him. And this was maybe early aughts. So I've been doing this for a few years, but I'm still in that phase where publishers say, "Oh, that's really nice. I'm glad somebody else published that." Now I mostly work for the New York, the big name, quote unquote, New York publishers. But this was just as manga was really hitting the U.S. and young women in particular were reading them a ton, way more than boys. And Scott observed this, and he said, if we just don't screw this up, in about 15 years, the publishing world will look very, very different. There will be room for the types of stuff that you do. There'll be room for a diversity of genres. It won't all be superhero. And voila, Scott was right. Somewhere in my slides, I have a slide that illustrates this, and I just list all the editors that I've worked with. And it's a list of 12 names, and they're all women. And all of these women came up through reading manga. So yes, I think there's a slightly different approach that you take to appeal, especially to young kids. I'm not sure I hope that wouldn't have to be true once they're high school and adult, but probably it is. But the world has changed drastically because of some really good imports into the US, and because that brought a lot of women into reading comics. And now, like I said, they're basically my bosses at Macmillan and Abrams and Simon & Schuster. Again, I'm not sure if I answered your question quite right, but.
We have a couple more questions from online. What translated versions seem to be most popular?
Oh, yeah. Hawking, a German publisher, ironically. I guess they found some of it important enough to publish. Hawking, Feynman, and the Niels Bohr book. I think Einstein's done pretty well, but it's still relatively new, and I haven't seen all the returns. Feels like, again, I'm talking about election, but yeah, Hawking and Feynman. Feynman is, people love that guy. I do too.
So there's another question from the same person. Do you tell the story of how Feynman came up with the Feynman diagrams and the logic behind them?
I try to. Yes.
Okay.
So yes, it's in there. Will it be enough for someone who already knows a lot? I'm not sure. I mean, the greatest compliment I can get for one of my books is, I read your book, then I looked in the references and back and picked out 3 or 4 of those, and then I read those. And now I really get it. It's like, man, that's a win.
Okay. Do we have any more questions? All right, well, let's thank Jim again for a wonderful talk.